Okay, so without further ado, we have the piston-driven automatic Mandoline slicer. What I did was I made a little crank. This could also be driven by a motor. And when I turn the crank, the piston slides the potato cage back and forth on the Mandoline. Right? So we can see the mechanism works. This was a learning experience for sure, in that as I tried to piece this together, I decided to use wood, and in retrospect I probably would have used something different, but I had wood. All my wood was so small that trying to attach with screws ended up splitting everything, even when I tried to pre-drill my holes. So all of this is glued together, which was super time consuming, and is a large part of why my project is so late. So some of the details that I didn't realize, things that you don't think about, is that, this axle here on the crankshaft, it can't go all the way through from one side to the other because the piston itself has to come swing through the middle there. So the precision required to get those axles directly across from each other and get all my holes drilled completely perpendicular to the surface, without a drill press, I couldn't really do that. So this is the best I could get. You can see the motion's a little wobbly. This hole here isn't drilled exactly straight. And so the piston itself kind of wobbles back and forth a little bit. But I gave it a little bit of play down here where it attaches to the potato cage. That's the name of this cage here, the potato cage. The potato cage is built out of small wood and popsicle sticks. You can see one of the details is that these popsicle sticks hang down below the edge, so that this will maintain a straight slide on the Mandoline at all times. Okay, so I have not yet tested this with a single vegetable in it because it's such a fragile dang project, that I wanted to get my first just spin of the crank on film before throwing any weight in there, because I'm a little bit worried. So let's find out. We're going to start small with some celery before we graduate to a potato. Again, the impetus of this project was on Thanksgiving. I don't know, we can't get that. I sliced off my fingernail. I can't get that to refocus. Using this Mandoline, this exact same Mandoline. Slicing potatoes for au gratin potatoes. So let me go ahead and raise the blade, if I can do so. Okay, blade raised. We're going to throw some celery in there to start with. And so cool thing is I can put the celery in here, and so that it doesn't fall forward, I've got these two little dowels, and the reason that this fence is slatted like so is I can insert these dowels to keep the celery vertical. Okay, so the celery is vertical, the blade is raised. This is my maiden voyage trying to slice a vegetable with the automatic Mandoline slicer. So here we go. Let's go crank this. Okay. Problem is, well, it's sliced, but the dowel is too close to the celery. It's not letting gravity do its work to pull the celery down. So that's an issue here. All right. What if we flip this, reorient the celery? I didn't count on the dowel providing that friction. What if I move this out a slat? here. Now the celery doesn't stand up very well. Yikes. We may just have to graduate to a potato as it is. And the celery has fallen over, but it's still getting sliced by the mandolin. All right. Experiment 1, a marginal success. I'm going to count it as a success because the mandolin slicer did not break, and I got 1 vertical slice of celery along with my initial slice, which is kind of right here. So we're going to just graduate to the big one so we can wrap this up and move on. Obviously, there are some tweaks that could be made to this machine to make it more durable and effective, but I really learned a lot making it, so I'm pretty happy with having something that is reasonably functional. And we shall see if it can do its intended task of cutting a dang potato so I don't have to cut my own fingers. All right, potato in. Potato's in the cage. The dowels are in place to hold the potato reasonably vertically. Here we go. Come on, potato. And as I suspected, it just, the machine can't withstand the torque it's gonna take to slide this potato through that blade. The stresses on this crank arm are too great to get that potato all the way through. So I guess ultimately I'd have to call this machine a failure, but I don't want to call it a failure. I want to call it a learning experience. I was able to slice through that much of the potato, and with just with a more cohesive mechanism, that can withstand stronger forces, especially the torque on that crank right there. I think that's the weak point in the whole system. If this was built out of metal or PVC with the same schematics in place, I think that we wouldn't have any problem getting that to go through. Anyway, that's my mechanical food project. I'm really happy with it, even though technically it doesn't work. I'm pretty pleased with how this all turned out. The automatic mandolin slicer with associated potato cage is at completion, at least for now. Thank you.